my name is Singing. I'm 15 and I'm in charge of presenting for my group EmOne. The challenge we choose is mapping space trash in real time, and we further build up from that by design and developing payload system for tiny and medium space debris mitigation. Our payload will protect satellites from collision, and when we have enough funds, we will also invest on collected target debris and recycling them. Our group consists of P. Anon, founder of EmOne and system engineer, P1, electric engineer, P. Liu, aerospace engineer, and me, a programmer. Debris has been a problem for launching satellites for a long time because it can cause substantial damage when they collide with satellites. For example, in 2007, FY1C collided with the debris and no longer functionable. And many more debris, which used to be the parts of FY1C, is created and needs to be managed as soon as possible. Otherwise, there are going to be many events like this happen in the future. In the pie chart at the left, it showed that almost half of the launching field is failed and causing even more space debris. The picture on the bottom left corner is an Earth modeling displaying millions of small and medium-sized debris orbiting the Earth in real time and can be visited on our website, emone.space. These are the data and statistics we gathered from ESA. The top part shows the object that orbiting the Earth and the percentage of it, and the bottom part shows the number of the debris. And as you can see, only 1% is a large debris, and 99% is a small and medium-sized debris. We see this as an opportunity because currently, almost every firm in the industry has their focus on large debris, which is only 1%. So we will have to focus on medium and small-sized debris. Another reason that we decide to keep our focus on small and medium-sized debris is that these are the type of debris that really cause a real problem here. Because the bigger debris is easier to see and avoid, but then small and medium-sized debris is like harder to do that. So our target is a debris that have size of 10 centimeters or smaller, which have like around 100 million pieces orbiting the Earth. Our orbit altitude target is also around 500 to 1,000 kilometers because it is where there is the highest level of debris. As you can see in the graph on the right, if we don't do anything about the debris, the number of it will rise sharply and will be dangerous in the long term for the satellites orbiting in the space. So currently, there are about 5 technologies that we can use to manage and get rid of the debris: impact absorber, evade, run and catch, shoot, and push and pull. Impact absorber is to build a payload that can absorb the shockwave when collide with the debris, but the payload will have to be heavy and big. Evade is to censor the debris from far away and try to avoid it, but it only works for big debris. Run and catch is when payload is sent to catch the debris in the space and destroy it by force themselves to fall into the Earth. But it will be a waste of resources because the payload will also get destroyed during the process. Shoot is when the payload will send laser to destroy the debris, but each time that they will shoot, they will have to gather a lot of energy, which means it can only occur once in a while. And push and pull. The technology we decided to use is push and pull because, as you can see, the number of support on the right of the table, every technology except push and pull is 1-to-1, which means it can only be used once, which is like kind of like a waste of resource. Our technology, we use an electric charge force field to redirect the direction of the debris, which according to our own experiment, it is working for many different types of materials. So this is the picture showing roughly how our payload system works. So it will sensor the debris from a distance away and prepare to change the debris direction using an electric charge force field and send it either to the debris orbit or make it fall down into the Earth direction and burn itself away. Our system will also track the debris after we redirect it, and like that debris might be the debris that we never discovered before. So it will further benefit the aerospace industry. If the system is working, our goal will look similar to this such a narrow ring. This picture is showing that currently every firm in the industry is working on get rid of the large debris, but only us working on small and medium-sized debris, which is the real problem of collision, as I already mentioned. So next up, I'll show our website. So this is what we made. So it is the website, and through here you can see like this one is like the space and displaying the debris, like as in the picture that I show in the presentation. And this section will be design and development of the payload system. That's it for our presentation. Thank you.